Fantastic. So this talk is called Web Components Are Your Best Friend, or Are Your Framework's Best Friend? And we're going to talk about web components and the major JavaScript frameworks of today and how they work with each other and some of the issues in that. The quick introduction, my name is Filip. You can find me on Twitter and stuff and at Filip Bech. I work at Collabo. We're a social collaboration platform, and that's a lot of fun. I'm a Google Developer Expert, so I get to sit down with the Angular team and the Chrome team every once in a while and talk about where they think we're going, and sometimes they listen to what I say. But this talk is really about the promise of web components, the promise that you can write your stuff once and reuse it anywhere you'd like. And web components are often confused with Polymer because the Polymer project was a project by Google where they tried to, grow the adoption of web components. And to a lot of people, they get them confused and think that Polymer is a set of polyfills or something like that. But Polymer actually runs on top of web components, and they come with a polyfill if you'd like, but they're just a framework like React or Vue or anything else. So just to clear that out, I think web components are finally ready, and that's what we're here to talk about. So we'll talk about the what and the why about web components. Then we'll have a very short tech introduction to web components if you don't know them already. Then we'll talk about the two angles of web component and framework interoperability. So how you use a web component from within your framework, and how you can build your component in your framework of choice and expose it as a web component so that anybody can use it without knowing what framework you used. The why is, of course, interoperability, portability. We want to be able to just take what we want and use it anywhere. We want to use a native component model. So over the last 5 or 10 years, pretty much all the frameworks has agreed that a component model is a pretty good way to build web apps. But they're all building their own version of what a component is and how it's implemented. And that hopefully someday soon, that's not necessary anymore because we can just use web component as the component framework or the component building block from the browser. And every time the browser gets faster, all our apps gets faster and we don't have to update our frameworks. So I think that's really nice. And I really think, more and more over the time that I've thought about this, I really think the framework should just be an implementation detail. Whatever you want as a developer, that's fine. You should just be able to use that, and you should be able to build anything with any framework. That's my opinion on frameworks. So this is the Collabo platform, and I'm not here to do a marketing material stunt. But I just want to say, we use web components for our widgets, so that if you want to write third-party code that lives inside our platform, you do this actually writing web components, and that's a pretty solid way to work with it. And I'm pretty excited about that. I could talk about that for years, but I won't do that today. And the great thing about this is that we're almost at a state where all the major browsers have support, and with Edge going to Chromium Edge on January 15th, we will have all the check marks done. So if you start a project today, by the time you will be able to ship it, web components are everywhere. So that's super exciting to finally be able to have a date and say this is the day where web components are everywhere without polyfills. So the specs of web components are basically 4. So web components is kind of an umbrella term to describe kind of the marketing term of why you would want or how you would want components in your browser. So the 4 specs involve a custom element, so the ability for you to make your own element in the DOM and attach some kind of functionality to it. Then it's the shadow DOM. Shadow DOM is like a tiny DOM that lives inside your DOM tree and that's encapsulated from everything else. So if you put styles in there, they don't leak out to other components, and styles from without don't leak into it. So you can make your date picker, and it looks the same in all browsers, in all platforms, no matter where it's used, because there's no collisions in styles. There's nothing inherited from other styles. It's all just the component model. Then it's the template tag, which It's a pretty simple API just built around making efficient templating for the web. And then it's ECMAScript modules. So I did a version of this talk, I don't know, 5 years ago or something, where I was still talking about HTML imports. Everybody thought that was going to be how we did imports in the browser, but like, thank to God and everybody, like this is ES modules is so much better a story, and it makes so much more sense. So it means that you can just do imports like you do in or like in Webpack or Rollup or whatever bundling solution that you do. So you do regular imports and then you import your dependencies. So it's pretty straightforward. So building that into a web component, like the basic tech introduction, looks like this. So you make your own class that extends the HTML element base class, which is like the base class for all elements in the DOM. So when the browser implemented the div or the span, they also inherit from HTML elements. So we do the same as the browser does. And then there's some callbacks for whenever stuff happens. So there's a connected callback for whenever your element is put inside the DOM. Then there's an attribute changed callback for whenever attributes changed on your object, obviously. A disconnected callback when it's taken back out. And if you're creating it like imperatively from code, there's also a constructor that's run whenever your class is actually instantiated. And then you define it as an element by calling custom elements.define, where the first argument is a string with the tag name in it, and then the second argument is the class. And that's how you build a web component today. One thing to note though is that class or the element names they must contain a dash in the name. So that's the way the browsers agreed that there will never be a collision between something that you write and any future addition to the HTML spec. So any HTML element coming from now on and forth is never going to contain a dash, and all your elements must, so that way they can never collide. So it's a pretty simple solution, but it's just a gotcha to know that you have to have a dash in your name. And what you're seeing here in line 3 inside the connected callback, I'm making the shadow DOM, so I'm attaching a shadow root to the page or to my element. And there are some different modes, and I won't even go into that today, but that's how you put stuff inside of your component. One thing to note though here, you see that there's the attribute change callback. And talking to front-enders all over Denmark, I see a lot of confusion between attributes and properties. So attributes are the ones that you put, like that you write in your HTML that lives on the DOM element. So that's what you see like in the inspector inside of DevTools. That's what you can target from CSS with attribute selectors. And since they're targetable from CSS, they're not really good for performance, because every time you change them, CSS has to do all its recalculation again. So only use attributes when you absolutely have to. So that begs the question, how do we then know when a property has changed, if properties are what we know? But since this is just a regular ES6 class, you just use setters and getters on your properties, and that way you know when they're changed, and you can hook into that and do re-rendering of your template or whatever you want to do. The reason why it's a little bit confusing is that some of the attributes are automatically reflected to properties, and some of the properties are automatically reflected into attributes, and that makes it kind of weird. And I hope that they could clean it up, but of course they can't, because that would break the web. So we're just going to have to live with that. But it is kind of weird, so you should just think of attributes as something you use to set an initial value for a property, and something you use if you need to style your component differently based on some data. If that's not the case, then you should use properties, because attributes can only contain strings, and properties can contain any JavaScript object. So objects, functions, arrays, booleans, anything. And in this example, there's a type attribute and a value attribute, and they set the initial value for the properties that are then used. There's a lot of properties on an element, even though you only define 2 attributes. But you see that if I then take my input element and change the value, it's going to be reflected back. But if I then change the value from the actual DOM, then it's not going to be reflected back to the attribute. So and that works that way for the value. But if you do the same thing with the type, that's going to be reflected both ways. So it's just weird and wrong, and there's no solution to that. So this is hard to read. So inside of frameworks, there's typically this thing where you want to when you use your element or your component, you want to be able to put some kind of template in it so that you can render out a list or something. The native way to do that is with a slot. So anything you put inside of the regular DOM of your element, so it's called the light DOM, anything you put inside the light DOM of your element, if you put in a slot tag in your shadow DOM, it's not going to show the light DOM and it's going to project it into. And it's called projection for a reason. So that means that styling is kind of weird because it's actually using the styles that was projected in, and it's a little bit of a hassle to get around. But it is a cool way to be able to have a dynamic template or something like that. There's events, like there's a slot changed event for whenever the light DOM has changed, and you can style it with a separate selector that's called slotted, so you can style whatever is coming in that way. You can do named slots by giving your slot a name with an attribute, and then whatever you want to go in there, use the slot attribute, and you can map that in there. So styling of web components is scoped to the shadow root, as I said. So there's no collisions between something inside of your shadow root and outside of your shadow root, and that's a really cool and powerful feature. The one exception to that is custom properties. So custom properties are referred to a lot as CSS variables. So that's where you make a property in your CSS that starts with 2 dashes in the name, and that way you can actually put in like a variable, and this custom properties will actually pierce the shadow DOM. So that's how you make a styling API for your element. You define that you maybe have a my header properties that you use for styling the header, and that way you can, from outside, the consumers of your element can set whatever styles you're going to use for the element. And then, as I said, there's some special selectors, like you can select the host, which is the element of the web component, so the custom element itself. You can do the slotted one to select stuff that's inside the slot tag. And there's a super cool new spec coming. I think it's just landed between a flag and Safari, which is parts, which is the ability to do like if custom properties are like a variable, then parts is like a mix-in, so you can actually like select a set of properties with values and pass them in as one variable. So that's super cool. It's not really supported anywhere yet in stable browsers, but it's coming, and I think that's one gap that the platform still has to fix. So that was the tech intro. I hope you're still following along. Now we'll dive into how we use a web component within our frameworks. So we'll build a demo of how to use it inside Angular, how to use it inside Vue, and how to use it inside React. And the base component that we're building is a pretty simple one. We're just trying to demo out some of the features. This is a component that has a shadow DOM, that has a template that has an H1 in it that reads some data out of a property and some data out of an attribute and shows it all along. And whenever it has a button, that whenever the button is clicked, it emits a custom event. So if you're used to writing modern applications today, that's probably pretty familiar to you because that's how most of them work. Then we define the element, and this is the element that we're going to use in all the applications. We're going to set this in and see how it works. And what I'm comparing here is feature completeness. So I'm going to show you how it's done in Angular, how it's done in React and Vue, and then I'm going to give it a score from 1 to 100 of how good is this framework at handling web components. And this is not something that I've come up with. Rob Dodson from Google, he built this website that's called Custom Elements Everywhere that takes all the frameworks and runs a similar component to this and runs a whole set of automated tests on them to see how they work. So I'm just using the score that he gave them. So of course, there's a certain weight between what scores are more important than others. So let's jump into it. In Angular, in order to be able to actually work with custom elements, you have to define it as the schema, or in the schema, the custom element schema, because otherwise Angular is going to think that you're trying to use an Angular element that doesn't exist. So you need to be able to, or you need to tell Angular that you want to use the custom element schema. So once you do that, this is a basic Angular component. I'm not going to focus too much about the Angular part, just saying that here in line 7, I'm setting in my my element component or element. I'm binding a prop to it using the Angular square bracket syntax. And if you want to bind to an attribute in Angular, you have to prefix the property name with attr dot. And then it's going to make an attribute with that name and bind to that instead. Event listening in Angular is done with the parentheses syntax. So here I'm listening for the custom event with the capital E and calling an Angular function that just alerts or whatever. And this works. Angular actually scores 100%. It works in all the use cases of attributes, properties, and custom events across the board, and it works. So Angular is 100% on this score. Then Vue. It's a pretty similar story. So this is the Vue syntax where you put everything inside one file. So there's a template tag which defines the template of your element or of your Vue component. And here you're seeing again that I put in the my element element, and the binding syntax is slightly different. So you use the colon instead of the square brackets, and by default you bind to an attribute. So here you have to suffix the attribute name with .prop in order to be able to bind to a property instead of an attribute. But it's the other way around, but it's more or less the same thing. The same goes for the event. So there's an @ sign in front of the event name, but other than that, it's the same thing. And actually, Vue also scores 100% on the score today. Then for React, it's a little bit of a different story. So React uses JSX typically for rendering, and inside JSX there are some limitations to how JSX is implemented. So here you see that I'm using the my element inside of my template, and I'm binding to, it looks like I'm binding to a property, but in JSX you can only bind to attributes. So this means that this is just going to be an attribute called audience prop, and it's just going to say square bracket object, because that's how that's how JavaScript works when it's trying to serialize an object into a string. So that's a little bit sad. The attribute works, so it can actually write out the attribute binding like that. But the event listening syntax in JSX is that you put on in front of the name. But since it's actually implemented as an attribute, and attributes doesn't support casing, you cannot have upper casing inside of your event names. So they must be all lowercase. So this actually also breaks. So you can only listen for the regular DOM events inside of React. So that's sad, I'm sorry. So React scores all of the basic tests, which means it won't break your React app to put a custom element in, but it actually fails all of the advanced tests. So the property binding and the events, they all fail. So React has a pretty sad score of 71. And if you want to improve this, please go to the URL and go to the related issues and start them up so that the React team knows that you care about this, because that's the only way we can make them do it. There's lots of talk about this already. I found on the React website that they say that they want to do this for React 17, or they say future work. And I found a tweet by Dan Abramov that says he hopes that this will go into React 17. So it is probably coming. There's an issue here that I'm actually this issue where they're talking about how to actually implement it without making breaking changes to JSX and how everything works. So go read up on this and start the issue and tell them that you want this, and that's how we're going to fix custom elements in React. So this begs the question: Preact, is Preact the savior here? Preact is better. It actually, because it supports binding to properties. So you can bind to properties, but we still have the problem with only lowercase event names. So it's still kind of a buggy experience of working with this. Of course, you can do this imperatively yourself from code. So you can like make a reference to your object in JSX, and then from within your React component, mount properties yourself and mount an add event listener yourself and listen for the custom events. And of course that works, but here we're trying to see how does it work like in a declarative way. Yeah, so yeah, you can do it, blah, 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 I just said that. So the interesting part really, I think, of this talk is how do we then use whatever framework we like to expose a web component that can be used anywhere. So what we want to build is, we want to be able to make a date picker in React and then use it inside of an Angular form and maybe ship that from within inside of a Vue application. That would be really cool. And with the, you probably shouldn't do that, please don't do that. But it would be cool that if you could. So I want to go through here why, how, and all the details around that. So of course, the why is still interoperability. I think the component developer should be able to just choose whatever framework they like. And there are two different ways of doing this. So there are some frameworks that actually build on top of web components. I mentioned Polymer earlier. There's frameworks like Svelte and Stencil and LitElement and stuff. There's tons of new frameworks that actually takes this approach natively, and they actually use the custom element as a base class for building components. And then there's the other frameworks, the most popular frameworks today, the Angulars, the Vues, the Reacts, the Embers, all the frameworks. And what we want to do here is really build our application or build our component out and then wrap it inside of a custom element so that we can interact with it as if it was a custom element. So we need to have some kind of binding between DOM events and framework events, or in React's case, like callback functions. We want to be able to support slots some kind of way so you can put slotted content inside of your custom element and actually have it used inside of your framework application or your framework component. And then we want to be able to have style encapsulation and event properties for data, so that whatever you put as a property on your element is actually going to be put into your framework component. So what I'm going to compare here is CSS encapsulation, the usage of slots, properties for inputs, events for outputs, and then I'm going to talk about it, which is a little bit more of a touchy-feely. I want to talk about how this feels to use, and of course that's very subjective. But I think as a developer, you tend to be pretty opinionated about what you like and what you don't like. So I think that's and this of course is just my take on it. Then I'm going to talk about the size of the bundle in these days where everything's mobile and you're on a crappy connection. If your framework within web components is hundreds of kilobytes, it's probably not going to be worth using. And I'm not going to talk about the framework integration of parts. So if you're using Redux inside of your React component, I'm not going to talk about how you then interact with the Redux inside of it, or how you interact with Angular services from outside of your custom element. I'm not going to talk about that because it's too hard to compare between the frameworks. So for Angular and Vue, there's an official way to do this. For React, there's a community-based, or there's actually a number of community-based ways of doing this. So what we want to build is a custom button component. So we want to make a button that has a label that's the property. So whatever text is on the label, it has a slot that it uses if the slot is present, and if not, it falls back to the label. We want to be able to just count clicks. So whenever we click the button, it's going to increment a counter, and then it's going to emit a custom event that's called action whenever whenever the button is clicked with the value of the count. Then it's going to contain an h1 and styles that apply just to h1 broadly. And then from inside of our HTML, we're going to use it, and then we're going to have an h1 that's outside as well with a different set of broad h1 styles to see that the style encapsulation actually works. All right? So for Angular, Angular has this project called Angular Elements. You add it by doing ng-add Angular Elements. Then, in order to turn on the real shadow DOM instead of the emulated one that comes with Angular by default, you say encapsulation, view encapsulation.shadow DOM. That means that all your style encapsulation is done for you, so you can handle styles like you normally do inside of Angular. The rest of the component is pretty much basic Angular stuff. So there's the label and there's the action that's the event name that's going to be broadcasted whenever the button is clicked, and there's a clicker that increments and stuff. The implementation doesn't really matter here. So in order to then make this as a web component, inside of your module, there's a function here called create custom element. That's an import that you get from the Angular Elements project. So you import that, you call the function with your Angular component and with the injector. And this is where it's kind of hard because of the way Angular works with dependency injection and all that kind of stuff. So I'm just gonna, not talk about that and say that we get the injector from Angular's dependency injection, and then we pass the injector down to the create custom element function, and then it works. So don't worry about that. Then it gives you back the custom element base class that extends the HTML element, so the class that you would normally do, and you call custom elements defined with it like you would any other web component. So that's how you do it in Angular. And you see that the result is the nice red header outside, the blue header inside, and when you click it, it increments the counter. And when we just, getting the button in order to do an outside add event listener on it, and I should probably type a little bit faster. So I'm going to stall here while we wait for me to type. We should see that after this, when I click the button, then it should log to the console the number that I've arrived at. And it works. So within Angular, it actually works really well. Angular has a thing that's very similar to how slots are implemented. So slot is, as I said, is the browser way of doing, taking whatever is in your light DOM and putting it in your shadow DOM. And Angular has a feature like that, and it's actually also called content projections, which is a little bit confusing. But I think they chose that name because they want to emulate how the slot is actually working. But it's only emulation. So if you use the ng content, that's how you do content transcription or projection inside of Angular. If you use the ng content tag, it works, but it kind of then doesn't work at all again, because then it actually copies over your DOM instead of projecting it over. So I would probably just go for the slot unless you have a very specific reason for using ng content. In order to make Angular a little bit smaller, we can turn off ng zone, which is Angular's dependency dirty checking mechanism. So then we have to handle all the dirty checking ourselves, but that's how you do it in all the other frameworks. So yeah, that's a pretty fair way to compare them. This turns out to work. A little bit of a big bundle here. We see that it's 49.9 kilobytes, so just short of 50 kilobytes. If you've been following along with the Angular community, you know that everything is better with Ivy. But unfortunately, I tried this afternoon with the RC2 of Angular 9, and they managed to cut off 3 kilobytes of code. So everything's not that much better yet. But there's a lot of promise of elements with Ivy, and they're talking about 15 kilobytes of code and all that kind of stuff. But none of that is in any stable branch yet, so we're not going to talk about that as if it actually happens or if it actually exists. So the Angular result is around 50 kilobytes of code. So for Vue, there's a similar project. It's called Vue Web Component Wrapper. You npm install it. You build your component like you would normally. You see that there's a slot tag in the template, and you do the regular event listening from inside Vue, and then it actually automatically does all the mapping. So whenever you expose a Vue event, it's going to expose that as a DOM event for you, and the properties, they're automatically mapped to props inside of Vue, so that works really nice as well. In order to make this work, it's a very similar process again. So there's a function called wrap that you import from the Vue Web Component Wrapper. You call that with a Vue instance and your custom or your framework Vue component, and that returns the custom element that you then call custom elements that define on, and the process is more or less like the Angular story here. It is a little bit confusing though, because when you use the CLI for Vue, it's not really built to work with this. So it actually doesn't work out of the box. So you have to do some, manual moving around of stuff. And in your build, like the build builds the main JS file as the entry point. But if you do that from when you're trying to build the web component, it actually breaks. Unfortunately, what I missed up here was that when you put in styles like this inside of the way you do styling in Vue is inside of the one component Vue file, you put in a style tag and then you put the styles in there. That's not supported in the Vue custom element wrapper. So they say, like the official answer to this question on the Vue GitHub repository is that you should probably use some kind of CSS build solution. So there's no good way to do this, and I've tried some of the regular hacks of placing the style tag inside of the template. That's not allowed. So the Vue compiler will die if you do that. And you can't put link tags, or you can't dynamically insert link tags with the style attribute on it, or style sheet attribute on it. So there's really no solution to this, other than it kind of sucks. So the rest of this works just as expected, although you see that the header here is just black. Building. The important thing to note here is that you have to actually pass in the Vue component file and not the main.js file as the entry point, and then it actually works. So the only blog post online that I've been able to find that talks about this doesn't do this right. So if you follow along that blog post, it doesn't work. So this is the way it actually works. So I thought I'd just put it out here in a slide so you can find it if you want to play with it. The rest of this is kind of self-explanatory. So you say that the target is WC, which is web component, the name of the component, and then the Vue component that you want to wrap. It feels pretty elegant working this way. Like the wrapping of the component feels pretty nice. It's a little bit weird that the event that it's actually the DOM event that it's actually passing is not the event value that you pass to the Vue event. It's an array where the first index or the first position inside of the array is the value. So that's just a little bit weird, and I think it's down to how events are implemented inside Vue, but it doesn't make sense to me. It doesn't handle styles. The bundle is tiny, but it requires a global instance of Vue, which means that it still beats Angular because Vue, the minimum bundle of Vue is kind of small, so it's like 32 kilobytes. But the component itself is only 3 kilobytes when it's gzipped, or 3.5 here. So that's pretty impressive. So if you're building custom elements this way with Vue, that's to be used in somebody else's Vue instance or inside somebody else's Vue app, this is an excellent choice. So the bundle is tiny and it just works. It's super nice to work with. React is a little bit different when it comes to events. So typically both Angular and Vue, they kind of have this thing where you do the event listening syntax, you put the at in front of the event name or do the parentheses around events. And that's kind of how you do data flow in React or Vue, or in Angular or Vue. But in React, if you want to do a thing like that, you typically pass down a function as a prop. And then from inside of your component, then you're going to call the function on the prop, and then it's going to take whatever arguments you want it to take. So it's a little bit different like that. And also typically, React almost always comes with some kind of CSS in JavaScript solution anyway. So it's a little bit different to kind of compare how this works. There's no official wrapper for React. There's a number of unofficial wrappers like from the community. There's two very similar named frameworks. One is called React Web Components, and the other is Web React Components. And I got those confused a couple of times when I was doing the work for this, trying to read documentation from one when I was using the other one, and that did not work, of course. Then there is a project by Adobe, which is super complicated, and I won't say over-engineered, but maybe. And then there's a wrapper like Skate.js, which handles more the other side of the equation. So it handles how you use web components inside of React, but not really the exporting of web components. So I'm just going to talk about Web React Components. That's the framework that I like, or the wrapper that I like the most. It's not maintained, so I don't know if it's a community project and it just, or if it was a prototype, or I don't know. But otherwise, it's more or less the same thing. Yeah, you npm install it, then you build your React component. And the thing again here is that JSX does not support that you put a style tag in it with CSS in it. So if you put CSS inside of JSX, it's going to die, and for good reasons. CSS is a security nightmare, but there's also not really a good way around this. So React has this feature where you can make an attribute called dangerously set inner HTML and give it whatever string you want, and it's going to take that and put it inside of your element. So if you do it this way, it actually works, but it's not really pretty. Let's say it that way. Here's the inside header. The button that has the onClick, because this is the native click event, of course that works. Then it's going to call the local click handle click function. That's then going to call the prop function that we pass to it, because that's how we do it in React. So we don't want to change how you actually build stuff inside of React. We want to make that work with web components. And the way that's done is very similar to the other frameworks, but even more explicit. So that means that you import the register function from web React components. You pass it the React component. You give it the element name. And then you pass in an array of all the properties that should be mapped to React props. So that's actually pretty nice that it's not some kind of magic thing, but it's very explicit. I want these properties to be mapped to props. So I like that a lot. And then it does the jiggling around of passing down functions as props in order to be able to actually broadcast DOM events, and that works out really nice as well. So you just pass in whatever function name or whatever prop name you want to have, and then the function that returns the custom event that you want to be dispatched. So it's actually pretty nice, and it works like you would expect. So with the style hack in place, this actually works out. It has all the features that we want to see. I don't want to bore you with watching all of this again, but trust me, it works. And the React results are pretty nice as well. It's a combined bundle of 42.5 kilobytes of code. So it's a pretty okay situation, although it doesn't really handles the CSS thing very well as well. So for the consumption of web components, React is a little bit lagging behind. The other frameworks are at 100%, so it works. For features, Angular works with all the features that you'd want, but Vue, a little bit, it misses the CSS thing, and the same thing for React. And the developer experience of wrapping it, I actually like the React solution better. I like being able to map very explicitly what events I want to be what properties should be kept in sync, and I think that's a really nice way of doing it. And when it comes to bundle size, Vue is the winner, even though it includes the Vue instance. So if you don't think about it and you build 3 web components, Vue is going to win even harder. Of course, you can do some magic and build one bundle that includes Angular or React, and then only includes the individual components, and is going to have an equivalent size. But the Vue building system is actually preferable, I think. So this begs the question: why do we need frameworks? Do we even need frameworks? And of course, I think we need frameworks. I think we need some kind of sugar on top of our component model. If you use a framework component model, or if you use the custom elements and Shadow DOM and all that stuff as your component model, that's fine. They can both do the job. They have more or less the same features. And you need some kind of sugar on top of web components if you want to use that. And if you use some kind of sugar on top of the other regular frameworks, it's more or less the same thing. And just to show you an example, if you've talked to me before, you've probably heard me rant on about lit HTML. So writing a component in lit HTML is very similar to how you actually do stuff. It looks a little bit like a mixture of Angular and React. So you do the decorator, so you say add property in order to be able to declare that this is like a magic property that should be re-rendering the view when it's changed. And then you have a render function, which is very similar to React and also how Vue can work, that returns the view. And this, of course, the consumption is 100% because it is web components itself. It has all the features. The developer experience is super nice, and the wrap bundle side, including all the dependencies, is similar to one component in Vue without Vue. So I think this is pretty nice, and I think that this is where the frameworks will go eventually. I think there's still some catching up from the platform in order to make web components perform better, and that's gonna happen, of course. And I think that's why the React and the Views and the Anglers, I think at least that's the excuse they use for not using web components as their building block. But the more that we have users with bad connections and stuff, the memory size, the low budget of your, or the low kilobyte size of your bundle, I think this matters a lot, and I think it's going to only matter more. It's kind of weird that even though our computers are getting faster and our phones are getting faster, the average computer or the average connection online is actually falling every year because more and more people are getting online where there's no good devices, or when there's no money and where there's no connection. So that's an interesting trend to look at, and I think this is why web components will actually end up winning this war. But as I said, the platform still has some gaps. Parts, the CSS thing, we really need this in order to be able to do regular, like real styling APIs for our components. We need some kind of scoped registries. There's some speculations out around how that could work. So the problem today is that if you have an element with a certain name and you pull in a dependency and they have an element with the same name, it's just going to blow up and it's not going to work. So we need some kind of way to make like custom elements defined only within a certain portion of your DOM. We want to be able to have import maps so that we can do imports like we do for real in Webpack and Rollup and stuff, so without all the actual URLs to the file, but I just have maps of short names. And still polyfilling is non-trivial. So if you need to support IE 11 or even older version of IE, this kind of sucks, because all the modern browsers, they need to have actual classes in order to work, and the older browsers, they don't understand classes, so you have to have separate builds and then load polyfills conditionally and all that kind of stuff. It's non-trivial. It's not impossible, but it's not that easy. So I think there's some work still to be done, and I think the platform has a little bit of catching up still. But I think web components, I think they complement each other rather than compete with each other. I think that frameworks will eventually go here, and when the platform eventually catches up, there's no excuse for the frameworks not to go that way, and we'll all be happy. We'll have date pickers that work in any framework that you'd like. We'll have bundles that are small everywhere and gets faster with every release of your browser. And let's make this happen. Let's go star all the issues with React. Let's go build stuff on this and prove to them that it actually works, and this is how you want to build. So that was it for my talk. Thanks for listening.